p.m. EST. And if you want to attend the webinar or you want to become be a guest speaker, so please email us at webinar@letustalkit.com. And this is a free knowledge sharing platform which we do for our community, and we hope that you will be all interested, coming together and make this whatever the initiative that we are doing a success. With that, we begin this week's the second day, this is Wednesday, our webinar, and the topic today is statistical modeling and optimization, and how these most demanding technologies are able to solve most of the problems in business verticals like CPG, pharma, retail, and others. And to give us, for this presentation, we have with us our speaker, Prabhakaran Chandran. And when I asked him about his achievements, he was pretty shy. But what I understood from his profile, that he comes from a rural village of South India, but has studied hard. He has studied in a government school, did his higher education in Chennai, but his aims, his dreams is big. He is passionate about artificial intelligence. He tries to learn new technologies each day, and his aim is to build an artificial intelligence based startup company as well. His hobbies are reading books, attending and doing webinars, and also he does learning sessions for rural colleges, which is amazing. And he has been awarded the star performer of the team in NLP in the computer vision category. And many people might not be very, know this factor, but still in rural areas of India, that people are very smart, but they are not academically educated. And here he says that he's the first graduate of his family. So I'm no wonder he's a great honor for the family. But today he is a great honor that he is with us, and he's the guest speaker. Over to you, Prabhakaran.
Yeah, thank you, Julian. Good afternoon, everyone. Today we're going to discuss about statistical modeling and optimization. Let's see the agenda for us for today. So for today, we'll be discussing more about what is statistical modeling and what are all the common business problems, and then how we can solve those problems using statistical modeling. Here, statistical modeling is nothing but linear regression models, non-linear regression models, and logistic regression models. So these are all the basic regression models which is in statistics, which has been developed 100 years ago, but still these models are helping us to make decisions and then solve the problems in the business verticals like pharmaceutical industries, CPG industries, and another industry like automotive and any other. Like if you take any business verticals, you have some problems. Those problems can be solved using these kind of statistical modeling methods, and also optimization. By combining these two things, as in statistical modeling and optimization, you could achieve two things. One is to predict the future, and another one is to prescribe for the future. As in, like, to predict the future, as in, like, you'll be foreseeing something. Okay, this is gonna happen, and then using the optimization you can avoid that, or else you can tune that with respect to your desired outcome. So we'll be discussing two things. So let's start. What is statistical modeling? So statistical modeling is nothing but a formalization of relationship between variables in the form of mathematical equations. Let's say, for an example, you want to calculate your health index, or else you want to calculate your marks that you're gonna score in the next exam. So based, you have some inputs like how many hours I'm studying, and then how many how much mark that I got in my internal examinations. This is two x variables you have. As in, like, you have two things. One is your study hours, another one is your previous marks. Based on that, you want to understand how many marks that you're gonna score in the next exams, or else like based on the calories that you're gonna eat, how that will affect your BMI. In business terms, you are increasing your price. You want to understand how that particular increase in price going to affect your sales. If you are running some promotions, if you are spending some money in market, a lot of social media platforms, and mass like mainstream media, and then how these media spends and are gonna help you, like how this will help you in terms of profit, in terms of return of investment, like that. So you want to understand these relationship. I'm spending some time, I'm spending some amount of money, or spending some time, I'm intaking some food in terms of calories, how these variables, x variables, affect your outcome. uh, to understand that relationship between those variables, like variable and predictor. Response variable is nothing but your y variable. Predictors is nothing but your like input variables. You want to understand that. For that, you need some mathematical equations. That mathematical equation will quantify the effects. Okay, like reading 5 hours will improve 10 marks or 100 marks, 10 marks or 15 marks. Increasing $1 of price of Coke bottle, or else like some burger, will impact your sales by $500 or $200. And then by adjusting the cylinder capacity of the engine, will impact the mileage per gallon, or else like horsepower produced by the engine. Like that, we are relating the changes happening in X, and then how it's going to affect in Y. If you know that, you can make some decision. Okay, this is the limit that I should follow if I want to get some good profit, or else if I want to get some good marks, like that. So this simply we can tell that we can define a statistical model with the formula y equals to f of x plus e. E is a random error, because we cannot fit our model with 100% accuracy. There should be some error. Okay, so y equals to f of x, as in f of x is the statistical model which will convert your x into y. So which will translate your x, whatever x that you are giving, that will translate that x into y as a your outcome variable. For example, we already discussed price and sales, and media spent and sales, and you can relate with your own data. If you have your fitness band data, like today I ran like 1 kilometer, 2 kilometer, and then my weight is this. If you have the data, or else like today I've eaten some 100 calories, the weight on today is 100 pounds. Like that, you can collect your data and understand it, and then you can do make decision making and then optimization. This is the overall idea about like solving the problems. So let's see, like what are the most common business problem that is occurring in the industry verticals. One is like to understand the various impacting sales. In the previous slide, we discussed like how it is impacting. For an example, sales driver analysis. For an example, one CPG company, let's say like a beverage company is selling some cool drinks. Okay, so you want to understand the company CEO or steering committee wants to understand what are the factors affecting the sales. Like, what should I do if I want to increase the sales? For that, you need to understand how the parameters, how the factors are impacting that sales, how each and every factors are contributing the sales. What if I? It is like a what if scenario. What if I increase my price? What will be the end outcome? What if I increase the marketing spends? You can easily quantify that, and then can make the decision. Another one thing is like to understand the price elasticity. This is the most demanding uh, like uh, kind of a problem in a CPG companies. Like they should know what should be the price limit they should follow for a long time, because if they increase the price certain after like beyond certain limit, that will affect the a lot. That is one thing. Another one is factors causing the customer churn and retention. Like how which factor is making the new customer, as in like bringing the new customer, which factor is causing customers to churn, whether it is age, or whether it is the interest rate and the income of that particular person. Like that you can understand why customers are leaving our company. Like that you can understand. Another one is like market shares driven by various reasons, as in like a company, as a company a company might have a lot of products. Like let's say like a company called ABC has products 1, 2, and 3. How these marketing shares are driven by some reasons, like the mainly caused by performance of one product is causing another one product. Let's say like it is more proven in Apple iPhones, like performance, or else like new Apple iPhone versions are causing the sales of the pre versions. Like if Apple is releasing i11, it might cause the sales driven or market share reduction of i10 or i6 or some other previous versions. Like that you can understand market shares. Or else like a company is releasing two products at the same time, how one product is affecting another product. More or less it is like a cannibalization, but it is affecting that market shares only. You can understand that also. And another one major thing is marketing mix. With this marketing mix only, it will lead to optimization problem. So nowadays companies are investing on multiple media. Some years, like a few years back, like some 10 years back, only companies are spending on print media and print media and television and radio. Nowadays a lot of social media platforms came, and then they are proven that social media platforms are more effective, they are reaching customers. So it is essential to it is essential to make a decision, how much should I spend on this media. Like you should not spend $100 or $1,000, which is very high to budget on radio, because nowadays radio is not having much importance, not having much audience. If it is Instagram or Twitter or Facebook that has a lot of active users, which could convert them to consumers or customers. Like that, some other using statistical model, you can do simulations also, which could lead to understanding the consumer behavior. Like how, like if you change a particular parameter, as in like in the autumn or summer, how consumers will behave. Or else like the consumer in Atlanta, the consumer behavior of Atlanta is differ from consumer behavior in New York or California, because the area, which is a geographical area, is making like impacting the consumers to select a particular product, because like one product might be very familiar in one area, which could be southwest or else like northeast, like that. So for these problems, the solution could be predictive modeling, optimization, and simulation. So that we'll be looking into like how this predictive modeling, linear regression is working, how we can use optimization, what is the backbone of that, and all will be discussing. Okay. First thing is linear statistical models. So the word linear is defined by the direction and the shape of the relationship between two variables. If you see in this one second. If you see this graph, um, I have time in weeks. and then I have y variable, which is, yeah, uh, y variable, which is accumulated savings. So you are a person is saving some amount of money over by weeks, and here the y is accumulated savings. It is because of like the accumulated savings is because of some amount of interest also, because you can think that okay, this guy is saving like 5 rupees every day, or 6 rupees every week, $6 every week. Ideally it could be addition of that particular amount only, but there is something called interest is also there, some variable amount is also there. So in order to understand what could be the accumulated savings after 52 weeks, or after 2 years, or after 3 years, like that. So this is the dots are the actual points, as in like in the first week he the accumulated savings is like 450 or $460. In second week it is like 1300 or 1400, like that. The accumulated savings is like vary across weeks. So we want to understand the relationship time, weeks versus accumulated savings. So we need to build some linear equation, so that that equation will define that value. Equation will define that accumulated savings with respect to weeks. For that, we have a backbone, which is a linear equation. We all know linear equation mx plus c. M is slope, and c is the intercept. So intercept means without any interruption of x variables, what is the baseline? So for here at the zero, so we don't have anything, but at zero we have something called c, which is intercept. The same thing here, in the week zero, that means before he starts saving, he has 470 or $450 in his hand. That means like I already have some savings before getting to before starting my like savings. So this is the intercept. Intercept means like without any interruption of any x variables. Let's say like base sales, like without any impact of your price, impact of your marketing. What could be the baseline sales? That means without studying anything, what could be the baseline marks for a good for an ideal student? He could score some 30 marks or 50 marks, so as a like a baseline without studying anything. So that is what intercept means. Another one is slope. This slope is like how this value is increasing, or is how this value is affecting that y value. So here the intercept value is 400, which is like before starting the saving, uh, the sales accumulated savings is 400, and then 307.50 is how this is increasing week by week. So if I increase week 1 to week 2, that increases $307.5. If I go to week 2 to week 3, that is increasing $307.50. This is called slope or coefficient of that particular value, weeks. So in a business terms, we can understand with respect to price and sales. So for price, this value could be negative, because the relationship, if you increase the price, automatically the sales will go down, because like people will might prefer competitors product, those who are following the same sales. This coefficient of weeks could be here, the coefficient of weeks is positive, but with respect to price it could be negative also. Let's see in the second equation. These are all the equation which is used for calculating the b0 and b1. In mathematical terms, we used to call this as beta naught and beta 1. Beta naught is the intercept, which we discussed already. Beta 1 is the coefficient of x. We have given the formula. This is the simple statistical formula using the mean of x and the mean of y, or else we can use correlation with x and y. Correlation is nothing but it is the quantification between two variables. How strong is the relationship between x and y? If it is positive, if you increase the x, if you tune the x, it will increase the y. That means here we have R equals to 0.83. That means weeks and accumulated savings are having a positive relationship. If number of weeks is getting increased, automatically the accumulated savings will increase. But if you take price versus sales, or if you take competitors performance versus your sales, it will be negative sign, because if competitors performance increases, your sales will automatically decrease. Or if competitors reduced their price, automatically your sales will increase. So that is the relationship, that is the point of correlation coefficient we are using. So in business terms, it will be useful to understand the scenario, understand the data first of all. So here we have a good business case study which we have to understand the simple linear regression, how we can proceed this linear regression to take some decision. So here, one concept called price elasticity, or else like elasticity is there. So it is not only for price; it could be for mm, any two metrics. Let's say uh, the goods and service tax, and then the GDP. If the tax is increased, how it is affecting the GDP, or else like the investment in a particular domain, and then the growth of that particular domain. Let's say like investments in IT sector, and then growth uh, of that particular IT sector, how it is varying. Like if I increase the investment, will it how much percentage will it increase, like that. For an example, here we have price elasticity, because like price elasticity is the most common use cases which demands simple linear regression. So price elasticity is nothing but a measurement of relationship between a change in demand and change in price. Like if I change my price, how it will affect my demand. That means how many quantities that will be sold in upcoming days. So a small change in service price that result a large change in demand. That means let's say a gold price is there. So a small change in gold, like $1 or $5 per gram of gold, might affect the demand, because people won't buy much, because gold is very precise one, and also a gold rate is high. So people might restrict themselves to buy that. So demand will automatically change a bit. And a large change in price accompanied by small change in demand said to be inelastic. For an example, even though if you increase the price of particular, if you change the price of particular product, there might not be demand. There might not be the good amount of change in demand. For an example, um, some high tech product, even if you change the price by a lot, the product demand might not be changed a lot, because the product's character, or else the product's brand value might not be uh, uh, that much to cause the demand. That is called as inelastic. Another one thing is, like if you change price, that will change the equal amount of demand. That means this might be like applicable in food industries, or else hotels. If you increase the price, or else I'm not saying increase versus increase. This is like the changes, like if you increase, the same percentage might decrease also. The Here is the formula we have: elasticity of demand equals to change in demand divided by change in price. How we can percentage change, we can rewrite as delta change divided by the whole value, which is change in demand divided by what is the demand, and change in price divided by price. We can rewrite this into some we can rewrite this into delta d divided by d, or else like delta d divided by delta b, which is like a change in demand with respect to change in price, that causes the beta value. So beta 1 represents what is the how much change will happen in y if I change something in x. That is what beta value. So you can replace this delta d divided by delta p value as beta value. That is what here we have done. So Here the price elasticity or else that elasticity has to be calculated with respect to income and food expenditure. So if someone's income is increased, will it affect the food expenditure much or not? For that we have equation, regression equation. Food expenditure equals to 83.416. Let's say this is a dollar plus 10.21 into income. So 10.21 is the beta value, and then the mean value of food expenditure is 10.96, and then mean value of income is $283.6. When I calculate this, the elasticity value is 0.71. That is less than 1, so it is inelastic. It is obvious thing. One particular person's income will not change the food expenditure of that particular family, because the food expenditure is not directly, or it is not only depend on income. It is depend on a number of persons and their past preference of food. This is how the price elasticity or elasticity concept helps companies to make decision on how to change or how to understand a particular variable with respect to another outcome variable. This is only one-on-one relationship, because here we have a price versus demand. But if it is some others, as in like a price and marketing spend, and then competitors price and your other products performance, it will vary. So let's move on to multiple linear regression. So simple linear regression, we try to understand the relationship and try to make decision with respect to one variable with another one variable. But if you want to understand sales, or if you want to understand the revenue of your company, you might need to understand multiple features. You might need to take a decision. Decision is nothing but whether we need to increase the price or not, and how much amount of expenditure we need to done on marketing, or else what should be the execution, or else distribution size of that particular product should be. Like that, if you can take decision on each and every value of x in order to reach out and decide y value. So the multiple linear regression equation is nothing but in a simple linear regression equation we have only beta naught or b naught plus b1 x1. But here we'll be having multiple x values accompanied with their effect values or coefficients. Coefficient is nothing but it is the quantity which explains the effect, amount of effect. For example, the sales in dollars is contributed, or else comprise of base sales, which is sales if you don't do anything. What is the baseline sales to the company? And then cost of the price and price. So cost of the not a cost, coefficient of the price. That means how this coefficient of how this price will impact your, how this price gonna impact your base sales or your sales. For an example, if you increase the price by $10, obviously the sales will reduce a bit, because people won't buy. Another thing is coefficient of competitor parameters. Let's say for competitor parameters, we have multiple things. Competitors marketing expenditure, we can get it through lot of data providers, and competitors price, competitors marketing activity, and then competitors brand value or some other value. Based on that, how it's going to affect. And then your marketing and promotions, as in companies marketing and promotions activity. So by calculating everything, because we have a lot of platforms to calculate these, like R programming, Python programming, even with Excel itself we can calculate everything. So with that you can waterfall chart. Waterfall chart is nothing but to understand the contribution, or else understand the parameters easily. The baseline sales is 100, as in $20 is contributed by your marketing, and $50 is contributed by the promotion. So your gross is 120. Out of 120, $50 is contributed by the promotion, so that you can still concentrate more on your promotion rather than your market, because marketing is just concentrate just causing causing $20 of increment, but a promotion is costing like $50. There should be a difference between marketing and promotion. Marketing is nothing but like it's simply running a like active ads, advertisements. But in promotions, like you will give some offers, buy one get one, or else like price reduction, buy two get one, like that. You'll be giving a lot of promotional activities, in-store activities, coupons you can give, like that. And then something like is reducing the sales, which is 40 minus 40. All these contributions you can get it from your end regression equation. Based on that you can take decision, or else like if you want to optimize it as in like okay, I could not take any decision, so that I want to do some programming so that I can get some optimal values. So you can move on to optimization. In order to optimize, okay, how much should I spend on marketing? How much should I spend on promotion? And then what to do to tackle the competitors' activity. So I want to reduce this minus 40, as in like a reduction of $40 to a reduction of $20. What should I do? So these questions can be answered through optimization. As in like answers as in like as a solution. Okay, you should do marketing spend for $100 or $200. I'm saying everything in a very small numbers. You can map it to 1 million per year. You should do marketing, 2 million per year for promotion. Then only it will give 5 million sales, which could give us the 2 millions of profit, like that. So this is how sales driver analysis works. You can understand the various factors impacting your sales. Uh, I didn't put much equation and its derivation, because like the aim and the objective of this webinar is to grab the relationship between the business problem and then how we can get the solution from the mathematical approach, statistical approach. If you get the solution design part easily, we can get into the execution. Okay, this could be the solution. Multiple linear regression, lot of other regression methods are there with respect to your data type, data distribution. Let's say sometimes your data might not be linear one, so you might need to do multiple quadratic or polynomial regression. Sometimes the data is not normal, as in like the data is not following the linear regression conditions. You need to go with non-parametric equation, non-parametric regression equations, which is splines, which is Mars, or else like exponential smoothing, or else like some smoothing functions you might need to do. Some localized regression you might need to do. Sometimes you might need to do penalized regression. These are all the different regressions, but the solution is in one word, that is a regression only. Everything is going to give you this attributions only, but the data type and data distribution different, because in order to achieve the good accuracy or good error position, like here the word accuracy will not be the opt one, but the error, reduction in the error, because everything is constructed using either optimal ordinary least squares or gradient descent or some other algorithms. So the objective would be reducing the error and then getting the good line, good fitted line, this line. Okay, so we discussed about sales driver analysis. Another one important problem which can solve through multiple linear regression is market mix modeling, or is media spend optimization. For that, you need some objective function which could deal with impact of all the media activities. So you want to understand your sales versus your media activities, which ad is working well, as in like which ad is performing well, and then which media is bringing you more customers to your sales. That sometimes you might running the company might running some 10 ads per day for a week, 10 ads per day for a week, and then the same thing in a Instagram, or else something Twitter and other social media platform. So the company wants to understand which ad is performing well, here the performance could be in terms of TRP rate, or else gross reach point, or else number of yeah, something called click views, and then how many views and likes is happened, like the interactions, the advertisement interactions. That is called the ratios. So these are the factors, or these are the data that you have. Based on that, you can easily understand, okay, TV media is causing good sales rather than digital media, and then competitors activities in this particular channel is causing yours, so that you need to move on to some other channel as in like a TV channel. And then how this is affecting like price and promotion is affecting that. Like that, you can make a mix as in like different combinations of the spend, how much I'm spending in TV media, and then how much I'm spending in digital media, like that. So in market mix modeling, your dependent variable would be volume trends. I want to sell 100 units per week, 100 units of iPhone, or 100 units of particular tech product in this week. So the independent variables would be mainstream media and post digital media spending. In the spending, like how much spend is there, and then GRP, gross reach point, and then digital spends, the campaign, and then views, magazine spends, and all, like by mainstream media. And then trade promotion. So there is two things with that. One is marketing, another one is trade promotion and consumer promotion. Trade promotion is nothing but how much promotion I have done to my customer as in like retailers, store shop owners, or it's like shopping malls, some supermarkets. So some price reduction, or some offers that I'm providing to shop owners, or some shopkeepers or sellers. And then consumer promotion is directly giving to consumers, which is like if I am the CXO, or some CXO of on how much price reduction I'm giving it to, like a buy one get one, or else like a 50% off. That is being factors of price and competitors activities. These are all the different things with respect to marketing related data. With this data, you can build a multilinear regression, multiple linear regression, and then using that equation as a objective function, you can do evaluating the marketing effects, as in like you can evaluate the present strategy. Okay, this particular promotion is causing low sales, so that we need to avoid that. And then simulations for future planning. So with that understanding of the present data, you can simulate for the future. Okay, in future, in next month or next year, I want to achieve a particular amount of x amount of volume trends, so that what should I do? So it is like future trends as in a planning, which comes as a prescription. So if you want to achieve these things, you should follow. It is like I want to be fit, so I want to take some vitamin tablets. Like that, I want to get some 5x amount of sales, 5x increase in sales, so that you need to follow these kind of steps. And ongoing is like day by day, you can understand it. So that is what sales or ROI can be attributed through baseline plus that same coefficient of mainstream and spent on mainstream, coefficient of social media and spent on social media. Like that, you can construct any equation. It is not only for companies like CPG, pharmaceutical, or else like automotive companies. The same thing can be done for process industries. Let's say like you are like doing some project scheduling, or else like process scheduling, which day, or like in which place that particular process, as in a drilling process, or else like some execution, a crude oil company, or else like a natural gas company is planning for drilling some oil wells or gas wells in a particular area. They want to do some project or process over there. They can they can schedule it. Okay, this time could be the best time for it. It is like a it is same as demand planning or as like a new product launch. Okay, this particular day could be the product. This particular day could be the good day uh, with a better reach. Like that, you can take a decision. So market mix modeling or else mixed modeling could be useful for a lot of problems, not only for marketing. It could be for project scheduling, and also it could be for process optimization. Okay, I need to set these kind of parameters to my process. So if you want to do some like fractional distillation, so these are all the things should be set to get the high output. So this is the overview and then overall understanding from multiple linear regression. And we have something called a non-linear regression. So non-linear regression is nothing but sometimes the relationship might not be a linear data. Let's say you are spending on marketing activities and then promotional activities. You cannot expect always that will give you the increased outcome as in like a linear outcome. Sometimes it will get saturated. For an example, even if you increase your study hours to 24 hours or 12 hours, it will not go beyond 100 marks. Sometimes there might be some breaking point. Studying 8 hours or spending $800 might give you the lower sales, but a lower outcome. But doing that the same thing with $600 or even lower, that will give you the higher outcome. This is what the different non-linear regression models. So if the relationship between x and y is not linear, we should follow non-linear regression models. The most common one is third degree polynomial regression. It could be any degree polynomial regression. Uh, but ideally it should be a polynomial regression only. But nowadays a lot of non-linear regression models are there, but they're not a statistical one. More or less tree based or else like boosting or bagging kind of modeling techniques. SVM is there, like that you can build a non-linear models. But here we have two different things. One is cubic regression equation. Another one is logistic regression equation. But most preferred one is like most used one is logistic regression equation in order to understand the propensity or else like inclination of y variable with respect to the x variable. For example, in logistic regression, the end outcome, which is the dependent variable, would be only two variables, yes or no, or else like the person can churn out of the company, or this he will not churn out of the company, or else like this is the good product or bad product. Let's say like if you are building a system which could classify the mails into spam or non-spam, or else like which could classify a person into fit for this company, not fit for this company, based on his performance in the tests, based on the performance test and the extracurricular activities. You can make into two ways, or else you can understand the consumer's behavior, whether they are inclined towards this company or towards the company or competitors company. You can calculate the propensity or probability of churn. Okay, we can get it from the last equation. One is log likelihood. Log likelihood is nothing but how likely to be that particular processes happen. That means what is the probability, how many percentage is possibility is available to happen for a particular event. Let's say like a 0 and 1 is for churn, 0 is for not churn. As like churn and retain. This could be easily explained in linear, but it has to be converted into logistic. Only easily get the correct relationship, because straight line might not cover most of the values in zeros and one range, but the sigmoid function or logistic function will cover. That is why we are using probability of x, probability of churn, defined by like exponential to beta naught plus beta 1. You can easily explain that. For a final propensity or probability of churn. Why I am this propensity? There is some method called propensity scoring, which will give us the direction whether they are churning to whether they are moving towards good state or else a bad state, or else you can use propensity scoring in a test and control or A and B testing also. This equation for a churn problem, 1 divided by 1 plus exponential of negative intercept plus effect of age and effect of income. So that you can understand whether this age is affecting churn or else like income is affecting the churn. If someone is age is increasing year by year, everyone's age is increasing year by year, but what will happen if someone's age is increasing? For example, like for a insurance company, the consumer churn will more happen in lower age, in the higher ages, because they won't prefer they won't like they won't follow the insurance because they might pass us away, or else like they might not able to pay the premium because their income is also the problem. So if the income is increasing, that will decrease because their income is obviously increasing, so they can able to pay the premium. And okay, we need to concentrate the customers, those who are in this income bucket. This is more or less useful in CIBIL score calculation also in the banking sector, like how whether we should the propensity score. Instead of propensity score, you can calculate the CIBIL score. The same thing, like if the CIBIL score is high, like higher than one particular standard point, if it is higher than 0.5, let's say in a whole number, if it is higher than 650 or 600, you can give a bank loan with respect to this amount, or else like you should not give it, like that, based on the customer's characters. How many dependents are there for this particular customer, and then what is the income, what is the age, and how many service years are there. Based on that, you can decide. In a banking sectors are deciding. This is the useful this is the application of a logistic regression in banking and insurance, or even in telecom industries also. Nowadays people are moving out to from logistic regressions to high end XGBoost, which is extreme gradient boosting, as in like even you can use logistic regression for consumer targeting, as in like to whom we should send the promotional emails, or to whom we should target. Like that, you can filter out the customers based on their inclination. Okay, these customers are more inclined towards a conversion, so we can target them like that. But nowadays everyone is moving from um, logistic regression to XGBoost, because XGBoost is giving more accuracy and also more efficient. um, so this is about two different things. One is linear regression, another one is logistic regression. How we can use it for understanding various parameters which is affecting some outcomes, whether it could be yes or no, as in like churn or not, or else like to target or not, to give the bank loan or not, or else like how the sales are affecting, how the profit is affecting, how ROA is affecting. These are all the most common problems that the companies are facing with respect to business decision, not as a data engineering or else like bringing the data. Okay, this is after getting the data as a data science part or statistical applications part. So this is just to get the function or just to get the understanding. But we have something to optimize. Okay, I have everything, but what should I do to reach the decide part? So I understand everything. That means like I understand marketing is causing the sales, price is causing the sales. How can I optimize that? Optimize as in like how can I bring it to more minimum or maximum position? That is what optimization does. So in optimization you have two objectives. One is you can maximize something, as in like you can find some maxima, or else you can minimize something. So for an example, in ROI, maximizing the ROI. So in marketing spent or in sales, you should maximize the return of investment. Meantime, you should reduce the expenditure. That is what good thing to the company. So for that, you need to get the decision variable. Decision variable is nothing but price, competitors price, or else like some other parameters, like if you take that in process industry, which place you should do that process, on which temperature or which atmospheric parameters you should follow. Like that, the decision variables are there. So optimization is the process to find the solution which could bring the optimization objective function to global minima or maxima. Sometimes local minima also. That is a very rare case. You might like you might stuck in a local minima, which is a trap. So optimization model has three main components. One is objective function, which you could get it from the statistical model. So if this is the statistical model for regression, so simply price elasticity model, or else the sales driver model, you want to increase the sales. So you can replace this increase, minimize with respect to maximize. Here I have taken an example for minimizing the expenditure. So I want to minimize the expenditure. So I want to get the variables, like what should be the A, what should be the A naught and A1, which is price and marketing spends, or else like promotional activities. So you want to optimize these three values, whereas you are getting minimized expenditure. So for that you need some uh, methods. It could be linear programming, which is simple algebraic calculation, or else a genetic algorithm, or else some extended versions of some advanced algorithms which could do the optimization. So these are the steps. One is construct an objective function from a linear model, or you can use any kind of model, but ideally you should get the objective function. Objective function is nothing but whether you should increase or decrease, and what is the characteristic of that function. For example, you want to increase the profit. How this profit is attributed for your parameters. Let's say you want to decrease the media spend. How this media spend is attributed by your different media and its rate. And then you want to declare something, because you cannot find some solution which is impossible. Let's say like you want to reduce the marketing media spend. Someone can tell that, okay, without spending anything, that is reducing media spend only, but you should spend something, but ideally that spend should be minimum with respect to maximum output. So you should declare some constraints, and then you can select a correct optimization algorithm and go about it. So here I have simple problem statement, which could lead to the linear programming based optimization as a simple programming you can do in R or Python. So I want to increase the ROI, whereas my equation is structured by 5 into print media spent plus 3 into social media spent. But I have some constraint. If I want to, I cannot put some $10,000 or $50,000, whereas I can easily get the ROI. No, we should not do that. For that only we have some constraints. Okay, my print media spend should not be less than $1,000, because the budget is that one only. My budget is $1,500 only. So it should be less than $1,000, and then it should be less than $500. So you can have a question. Okay, why not? Why should not I use $1,000 and $500 directly? No, because if you optimize, you can save some $100, right? So even there is some space for minimal or maximum values. That is what the like this optimization equation and constraint helpful to reach out that particular point. And after that, the last topic of this webinar is which is genetic algorithm, because no, previously everything is about with very simple algorithms like a simulated annealing, which is like a thermodynamic uh, inspiration, and then something called hill climbing or greedy algorithm, that are all very mathematical algorithm. They got it through some derivations, some equations. Even Newton Raphson and some other algorithms are there, which is came through some came as a byproduct of some inventions. But here we have something called bio-inspired optimization algorithm, which is the product of inspiration from the biological beings. It could be inspired from a rat, it could be inspired from the ant, it could be inspired from the birds. Here the algorithm is inspired from the human genetics. which is even not even human genetics, it is the genetics, because this process is happening in all the beings. Let it be a plant, or let it be a ant, or let it be a tiger. This crossover mutation, everything is happening all the beings. So genetic algorithm is nothing but it is inspired from the biological genetic process, which is like a biological reproduction process. In this, the solutions for the particular problem, solution as in you want to get some optimal price and optimal media spent, or else if you want to get the optimal temperature and optimal cylinder size to get the maximum mileage, like that you want to achieve. Okay, for that the first step is initializing the solution. So each solution, one is one solution, as in like $1 is one solution, $2 is one solution, like that you have a solution, initializing the solution. From that solution you are selecting something. So first step is to select something. Okay, I have some set of solution with respect to some constraint. Okay, the solution should not beyond some certain limit. Within that I have some selection. After that we are setting some common genes, which is like, okay, we can use this solution for a crossover. So crossover is nothing but uh, calculating the solution whether it is fit or not. After that you doing something called evaluation, which is like, okay, whether this particular solution, as in the solution is got from the initialization, is fit or not. Based on that you will be doing the crossover. After that something called mutation is there. Mutation is nothing but adjusting the solution, as in like, okay, we got $2 is a some nearest value, but we need to adjust, so we can adjust it like 2.5 or 2.9, like that you can adjust. This is based on the bytes or some string values it is given by. But the understanding is, but the fact behind the concept behind the genetic algorithm is, first we will be starting the initialization process, in which we'll be having multiple solutions, and we'll select the solution and calculate the objective function. Again we'll go on with the mutation, that is adjusting the solution by a bit. So it is like we will be doing until we are getting the convergence. Some other optimization algorithms are like particle swarm optimization. Swarm is nothing but a group of animals. Like it could be birds, it could be fish school also. So based on that, how they are selecting the particular space, and then how they are making the distance, calculating deciding the distance. Okay, this is the less distance with the good amount of food, so we should follow this only. That is also there. And cuckoo search algorithm is there. Cuckoo search algorithm is nothing but how cuckoos are searching for the correct nest, which could be the perfect habitat for it. Like that, cuckoos have some properties or characters to select that particular nest. That is what cuckoo search algorithm. And the ant colony algorithm is like selecting the minimal path, like that, selecting the correct optimal solutions you can do. So this is got it from the nature of ant. Firefly algorithm also there, how the fireflies are following one firefly from another firefly. Like that, a lot of bio-inspired algorithms nowadays are getting used in solving the business problems. Yeah, that's it about the small content for 1 hour, which I wanted to cover. Uh, I wanted to connect the dots, problems and the solutions available in statistics. How we can use it. If some students or some IT professionals, those who want to build their profile, they can connect any one of it. Like, okay, you can get some data from some online portals, and then you can build some market mix models, and then that you can optimize it through particle swarm optimization or cuckoo search algorithms. The same thing you can build as a product, which could lead to a startup. As in, like, nowadays a lot of companies are having some optimization platforms. Some companies are having some sales driver platforms. Everything is like a front end or some product development stack plus statistics or machine learning stack. If you fuse both the things, it could lead to a good portfolio improvement idea. Or else, if you are a pro person, you can build your own startup or else your own concept, your own product of small size. That is what my aim is also. Somehow our learning should transform into a product or a like notable entity. Yeah. That's all about our discussion topics. If you have any questions, you can ask. Hello.
Yeah, thank you, Prabhakaran. That was, taking almost every one of us back to college days, and then, slowly building it up. Very well said and shown and done. Thank you so much. So, yeah, any questions? Please unmute and ask. Any feedback? Okay, while they are thinking on the feedback and the questions, let me just remind that we have these webinars every Tuesday, Wednesday, Thursday, and we have again tomorrow. And our topic will be, will robots replace humans? Are our jobs at risk as artificial intelligence takes more center stage? So it will be an exciting topic and discussion. So please do join us tomorrow at 12 p.m. EST. And again, on Friday, we have Let Us Talk It Youth series with another powerful topic, absolutely by the youths, and they are working hard on it. From 4 to 5 p.m. EST. The topic is pouring from an empty cup, how we have to take care of our own health, mental health specifically, and others' mental health in the long term to be to be of need and to help each other out. So that's the topic for Friday. And yes, we do have professional webinars, and if you want to participate or to present, please email us at webinar@letustalkit.com.
Yeah, thank you so much, Prabhakaran. I think that's a great overview of the science behind statistics. I would really love to catch up with you on how we can practically apply to any business solutions, because I know you seem to have very thorough knowledge, and then hopefully you can guide us. We'll definitely stay in touch with you on that.
Yeah, thank you. So if it is possible, we can get connect on LinkedIn also.
Yeah, sure.
Yeah, thank you.
Absolutely. So thank you, Prabhakaran, for your time, effort, and that zeal to, tell what you have. So that was, inspiring, and definitely, I hope others have taken also something from your presentation.
Yeah.
And thank you, audience, for joining in.
Thank you. Let us talk it team and Julian for this opportunity. Yeah, thank you everyone for.
You're welcome, and it was our pleasure. Thank you, everyone. Have a great day ahead, and don't miss to join us again tomorrow at 12 p.m. EST. Thank you, everyone.
Yeah.
Bye.
Bye-bye, all.